Hello guys and welcome to lesson 3 of our course, which is titled Building Secure, Scalable, Fault-Tolerant and Low Latency APIs with Java and Spring Boot. My name is Ngane and I'm a software engineer with multiple years of experience in building scalable systems. And today we are going to talk about REST API design fundamentals. For the last two lessons, we have introduced the whole idea of APIs. We have also talked about, in the second lesson, different APIs and API architectures, where we got to see the REST API, the GraphQL, and the ROPC, which is a remote procedure calls. And we got to explain the different use cases for each and some other information that are very helpful when designing APIs. So today, which we are going to be talking about REST API, which is going to be the API we're going to be using, the API architectural style which we are going to be using in the entire course most of the time to design our APIs. So we're going to be working with REST. We're also going to be seeing remote procedure calls in the later videos when we talk about service-to-service communications. But for now, we're going to introduce REST APIs. And so if you are liking this series this course thus far, please give this video a thumbs up, comment your questions in the comment section below, and I'm going to get to you as soon as I can. Also, you can connect to me in my socials, which I left in the description below, and we can talk about important and fun stuff. Also, if you have any requests, you can leave them in the comment below, and I will try my best to reply to them with a video or two. Without further ado, let us get into the course, in this particular video. So let's dive right in. So the lesson context for today, we are going to be looking at why API design comes first. API designs, define how clients interact with your system. So before I continue, again, like in the last video, the couple of videos, these beginning videos, I think lesson 1 to 3 are mostly introductory videos, and this theoretical part, the slides are so detailed that we are just going to be reading through, but I'm going to try my best to explain certain things that needs further expatiating on top. So stay tuned, and I hope you like this time. So like I was saying, API designs define how clients interact with your system. Okay, so poor designs are not accepted when designing API because they can cost you a lot. We're talking about confusing usage within your organization between developers, security gaps which can land you in prison, and at the worst case scenario and cost a lot of money for your company, breaking changes which can be a pain to fix, and performance problem which can cause your application to be not usable and cost you a lot of money. So good design is a must because it enables scalability, maintainability, evolvability, right? So designing is an engineering decision, not an aesthetic. So the learning objective, so by the end of this course you should understand REST API principles, right? You should learn how to structure endpoints, use HTTP methods correctly, that's understand what HTTP methods are there, understand API versioning and why it's important to version, know how to pass data safely. We're going to look at different ways to pass data to your APIs and avoid common mistakes. So what is REST API? REST API stands for Representational State Transfer. It is an architectural style for designing network application. Okay, so the principles of REST API at the higher level. They are stateless communications, they are resource-based URL, they use standard HTTP methods such as get, post, put, patch, delete. So they have a uniform interface, they are cacheable, and REST improves scalability and simplicity. So it's easy to scale REST APIs and it's simple to really build. There's a lot of libraries out there, a lot of tools, frameworks that have made developing and scaling REST APIs very easy. And we're going to see Spring Boot, which is one of the things that it's just been a game changer for the Java community. So designing resources in REST. So when you're designing, especially API, we're designing resources. We think in resources, not actions, right? So one of the mistakes people make when designing API is that, especially API endpoints, is that they use verbs to design their endpoints rather than noun. So what you don't want to do is say get verb. You don't want to send a get request to get user, right? So get user or create order or delete product, right? You want to use the noun. So you want to say get, which is the request which you are going to see. You're going to see the when we're going to get to the thing in further. Yes, we're going to see something like this. You want to use get, which is the request type, and then the URL, and yes. So we are going to get the request URL there. So the request path, sorry. So we're going to get user and then the resource ID. So which is what we're trying to explain here. So we want to use we're going to have the request type, which is a get, not the verb get user, but the request type. And we're going to get the request type, get order, and get product. We also use post users, post orders, or delete product. So bottom line is when you're designing the endpoints, you use the noun, which is slash users slash product slash orders, right? So we're also going to see the different hierarchy, which is the next slide, and you're going to see the different ways to structure your endpoints in a hierarchical manner, and you're going to have like the users and slash users ID and slash order slash user slash ID. And this reads, and it's kind of easy to read this because it is expressed naturally, right? These endpoints, is you look at it, you say, okay, this is like get all users because it's plural, right? So get all users with ID that is specified here. And then this one we get all orders for users with ID, which is specified here. Okay, so it is easy to read because it flows naturally. The hierarchy is explicit. It is shown. It is expressed it's easy to read because it's just expressed in the terms of it's cleanly designed. I don't know how else to express it, right? So that's how you design API endpoint. Okay. So common HTTP methods, we have get, which is used to retrieve data, post, which is used to create new resources, put, which is used to replace resources, and patch, which is used to partially update, and delete, which is used to remove resources. So these are the most common HTTP methods we're going to be using for all. So usually they usually call them CRUD, which is create, which is post, read, which is get, update, which is put, and patch, and delete, which is delete, of course. So it's the acronym they always use for this is CRUD, which is CRUD, right? Create, read, delete, and patch, and create, read, update, and delete, right? And so the create is post, the read is get. So you are reading data from the database. You're creating, you're posting, you're updating is you can use put and patch, but they have their specific ways of using them. And then the delete, which is to remove resources from the database. So idempotency, right? This is another very important thing you need to understand, and it's very important for retries and for tolerance. So what is idempotency? Idempotency talks about whether or not you get the same result if you run the same query. So an HTTP method is idempotent if you can run the same query, the same request with the same parameters and get exactly the same result. However, if you run the same request and get different result, then that HTTP method is not idempotent. So if you say, okay, I want to get all users with a particular ID, you realize that you always get the same user. Okay, because that query will always, if you run it 10,000 times, you always get the same user 10,000 times. If you want to update the name for a particular user, so you update the role, update the name for a user, again, that query will run 10,000 times and perform exactly the same action, and the result will be the same. Same for delete, okay? Same for delete. However, when you are posting, when you're creating new resources, each time you create a new resource, if you run the query, the same query 20,000 times, you will get 20,000 new resources created, because post is used to create new resources. So each time it's going to create a resource with a different ID. So the result of that is not the same as the last one, because at least the ID has changed, different things have changed, and so it's very important to keep in mind the idempotency. Okay. and we're going to see in the potency API design, because when you're looking at retries, this comes into play. So we're going to talk about passing data in APIs, and there are four main ways of passing data in APIs. And the first one is path parameters, which is used to identify a specific resource. Okay, so example, as we have seen, the get, which is the request type, and then the path, right, which with the variable, and which is a value. In this case, the user want to get is the user with ID 123. So we're saying get users with ID 123. This is going to return a single user. Okay, so if you run this 20,000 times, you are always going to get the user with ID 123. It is never going to change. So it is idempotent. So I'm just going to touch that particular one a bit. And so this, we are passing the data in the path, because this is the path of this request, and this is the data at the end of that path. And again, if you look at the hierarchy, this is the same particular query, just that in the position of this ID now, we are now passing an actual ID. So you realize that that path parameter, this is the parameter we have defined here, and now this is the ID, right? So we use when the value identifies the resource. So in this case, the resource is a particular user. That's what we want to get from the database. So the next way of passing data to your API is the query parameter. And this one is used mostly for filtering and sorting and pagination. So examples, I think you have seen when you're browsing, if you go to Google and type something, you see a query like this. You see maybe google.com, and then you're going to see a question mark with a particular name equal to something, very long text. Most of the time they encrypt this. You don't see them in plain text, they encrypt this. You're going to see some long strings, you cannot make sense of them. But you're always going to see something like TF or something equals to a very long string. That long string is the value that has just been encrypted, and so doing security is important. We're going to look at that when we are talking about encrypting your path, your values in your path, to avoid hackers from using your information in order to get access to data that they're not supposed to get. But for simplicity's sake, to make you understand, these are path variables, right? So these are query parameters, sorry. And the query parameter is a rule, and the value in this case is the admin. And in specifying query parameters, they always come after the question mark, and you are going to get the parameter itself and the value of that parameter. And then the next parameter is always going to be separated by an unsigned. Then you're going to have the next parameter is a page, which is the value is going to be 2. So if we're going to have another parameter, we're going to just add an unsigned here, and we're going to see like limit is going to be like 10 if you want to get each time we're getting the particular number of users, 10 number of users or something. So again, it's very important to remember that you don't use sensitive data in here. Okay, and that's very important, because this entire query is going to show up in your browser URL. And that is why it is sometimes, even if companies like Google tend to encrypt their entire URLs, the values, for example, the admin, this can be encrypted to a random string, so you don't exactly know what it is. It is going to be decrypted in the back end, and then you're going to get the actual value. This also can be encrypted. It depends on what is sensitive and what is not sensitive. But typically, for something like a row, you don't want to put it here. You want to put it in the next one, which is the header, because the header is where things that are used for authorization and authentication are usually sent. So if you see here, you have authentication used for metadata, for like authentication, content type, and correlation IDs. So authentication and authorizations are usually sent through the headers. So something like your role will be in the header. Especially if you're using like a JWT token. If you're using like a JWT token, your token is going to contain like your username or whatever identification you have within your token, and you're also going to have like your roles in order to confirm authorization to access certain resources in your database. And we're going to see samples of this in later videos within the series. So the next way of sending data to your API, passing data to your API, is called the request body, and this is mostly used with post and patch. An example of a request body is like this. So Yeah, example of a request body is as this a JSON format. We have like a name, at least email, at least blah blah blah. So you can have comma. You can also have like the school or the gender. Yeah. So you can send as much data as you can here, and it's mostly used to create a new resource, update a new resource, and so on. So that is what we want to do. So that those are the four main methods of passing data into to your API. So the next thing we're going to talk about here is the API versioning. Versioning is very essential because in today's world, APIs evolve over time, right? So clients are dependent on existing behavior. Things they change, some clients would have already implemented the existing behavior of that particular API. So you don't want to, make an update that breaks changes. Okay, so when you do that, you want to make sure that you manage those breaking very safely, right? And you are going to use versioning, and then you're also going to deprecate those versioning over time slowly to make sure that the people who are your clients who have implemented the APIs transition to the updated version gradually without breaking the entire system. So we're going to see that in later videos. So I will talk more about it. So versioning strategies we are going to have. So we're going to have there are three main ways of versioning your APIs. The one and the most popular is the URL versioning, which is what we're going to be using in this video, in this series actually. And you're going to put the version in the URL or in the path of your API. This is mostly done in the back end, right? In the back end, you're going to define your API endpoint. You're going to put the version there in the path. And the next one is the header versioning, which is sent through the header, and you're going to put the version in the header, right? So version 1. So the other one is the query versioning. Again, this is going to show up in your URLs, and also you could also like encrypt all of these. I don't know, right? But again, if it is a sensitive data, you want to encrypt this. If it's not, if you must pass it in the query and it's sensitive data, that it's important to encrypt it before sending it there. Just making sure that I say that over and over again, because security again is not an afterthought, it's a must, and you have to build your API with security in mind. URL versioning is the most common. So versioning best practices, okay. Only version breaking changes, right? So endpoints that require updates, maybe updates that will probably break client implementation, right? That's the kind of endpoints you want to version, right? Endpoints that you can implement backward compatibility rather easily. You can extend without breaking the client. Then you don't. Sometimes you might you don't want to version it. You can get away without versioning it, okay? But it's important that you check, especially those endpoints, those APIs that are they are very sensitive when it comes to update. Any small change could literally break the entire client implementation and return unpredicted output. So you want to version those kind of API endpoints, right? So you have to version those type of APIs. So avoid unnecessary versioning. Again, too much versioning is not very advisable. That's why I say it's sometimes if you have endpoints or APIs that can do with backward compatibility, which means that new versions don't essentially make the old versions useless. The you can like extend them rather than just deprecating them completely, allowing those who have implemented your old version and those who are implementing the new version use them without a problem. Then it's very good, and then you can allow it like that, especially those endpoints that don't require frequent changes, right? Let me say like a delete endpoint where you just want to delete the resources. It doesn't really make sense to version that one, right? But if you have like an endpoint that says it compress a particular data, and in one endpoint you're using one API, right? You're using a particular algorithm that achieve a particular result, and then the next API you're using that algorithm that achieve another result. Two clients might want to use two different algorithms because those results can produce output in two different formats. Also, you can have different APIs that return allows you to specify different parameters, and adding new parameters require you to take out some other parameters or change the naming of other parameters. So those kind of APIs are good for versioning. However, simple APIs that, just like a delete API that just simply just remove a resource from the database. There are not like 10 ways of deleting a particular API. But also, you can have some deletes that get a little bit complicated, especially when you're dealing with how they calling it, this n+1 query problems where one action gets to cascade down, right, to the other resources. So deleting one resource may require you to delete multiple resources. So at one point you may want to delete a resource that don't delete another resource, and your implementation might change for that delete. So sometimes implementing versioning there could make sense, but for the most cases, it's you can really get away with just not versioning that particular part. But anyway, you have to understand what you're building for and think whether or not you have frequent updates and your updates will break the client implementation. If that's the case, then you want to implement versioning. If not, then you can just skip versioning for that particular API. So deprecate old version gracefully. We'll talk about that, and communicate clearly in your documentation, of course. Status codes and errors. So these are common topics. So some common status code are 200, which is the OK, 201 for created, 400 for bad request, 401 for unauthorized, 403 for forbidden, and 404 for not found, 500 internal server errors. So generally the 200s, right, from 200 to 299, they're usually for OK. 400 is for client errors, right, and then 500 are for server errors. Is it 300s are for, I think I've forgotten this thing. But I think 100 are for information. I think 300 are for migrating or like permanently move. But anyway, you can Google that. Yeah, so again, software engine, you don't have to know everything. You can, like, it's a continuous learning process. You get to know all these things that you forget. But I think 100 is for information, I think, and then 200 is for successes, 300 is for like migration or something, then 400 is for client error, 500 is for server error, if I am not mistaken. Yeah, but again, you can just simply Google. Okay. So error response design, return structured errors, right? So we have errors. So when you're designing your errors, when you're returning an error from an API, say you send a request and then an error occurs, it's very important that you don't leak internal operations, internal details. Okay, you don't want to be too detailed in your error messages. You want to return error quite all right, but you always want to be generic. You want to give just the information that is needed for them to understand that a problem occurred, right? And and it also depends on the API. So if you are using like a shared API, then you want to maybe go a bit detailed, because you are now dealing with partners and people that implement your API. So you want to tell them and teach them in your errors, and let them also track and understand what problem that is happening doing that errors, right? Doing those errors. But you generally want to avoid too much detail in your error messages, because these give hackers the idea on what they are probably doing wrong, and give them enough time and enough information for them to make certain changes and get it right. And that's what you want to avoid. So you want to use generic messages, right? So error, invalid request, right? Message, email is required. You don't want to do that, right? You don't want to do that. So if you have method invalid request and image required, you want to just say like a generic message here, like validation. Let's just say field missing, or let's just say authentication failed. Okay, something like that. So again, if it's a public API, you want to use very generic. If you say a shared API, something that is just within trusted organizations that you work with, you want to be a little bit detailed. And if it is internal APIs, again, generic, you mostly want to use generic, but that's where logging comes in a little bit. you want to use a bit of generic but point them to the right direction, especially when you're using between internal APIs and that's private APIs and shared APIs. And then you want to use logging because they have to now look at the logs to, they will probably have access to the logs to see what is going on. Okay, so you want to use a mix of them, but generally it's a rule of thumb to use generic messages and not to expose internal details. Oh, yeah, so pagination and filtering, we also talk about that. So avoid large responses. We're going to see this particular topic when we're talking about latency and speed optimization of our APIs, where we're going to be making requests that is going to be returning thousands of responses, and that is going to be so long, and you're going to measure the response time when we implement pagination and when we have not implemented pagination. So, but this is an example request with pagination. We have the page one and size. Also, there are two different types of pagination. The generic one, and also have like a cursor, where again, it's going to I'm going to explain it in due time when we get there. Filtering and sorting, again, same idea here. We're going to pass it in, as query parameters. We saw that earlier. So these are all query parameters, as you can see. Same format. We're going to pass it as query parameters. We're going to sort them in terms by status of paid and sort by date, right? Okay. Common design mistakes, right? Using verbs in URLs, explain that, ignoring HTTP codes, very important. When you're returning the response to your client, please always return with an HTTP code. They use the HTTP code to determine the state of the request, okay? Whether the request was a success or there was a fault and what type of fault. It is very important to always return your HTTP codes. Overloading an endpoint, right? We're going to see that. Breaking clients unintentionally. We want to make sure that your design doesn't just break clients. You want to use versioning, it's very important. We saw this. Mixing responsibilities, again, we don't want each particular endpoint should only handle one responsibility. In fact, when you're dealing with microservice, we group response. When you're dealing with designing of a system, we talk about microservice, and microservice allows you to separate responsibility. So you can have like an authentication service which is responsible solely for authentication, everything authentication. And so all the API, that particular API is just for authentication. So all the endpoints there are specific for authentication. Okay. So you want to make sure that the responsibility for each API is just a single responsibility for each API. So inconsistency in naming, you want to use consistent naming because you don't want your clients to be confused. You know, you're using a particular naming format here, user slash user slash ID, and then down there you use slash ID slash ID slash product. No, you don't want to do that, right? You want to use slash user slash ID and then slash product slash ID. It's because it reads the same thing. Get users with ID, get products with ID. Okay, so the naming has to be consistent. So why design enables security and performance? So good design simplifies authentication. Okay, again, if you have a very good design, it's easy to authenticate each particular request. It's easy to authorize the particular request, right? It enables caching. You can easily cache in a good design. If your design is bad, it's really difficult because you can have very complicated caching problems. Right, you have improved monitoring. Again, you can monitor each API with their monitoring stat. We are going to see this using graph. Is it Prometheus? Yes, we're going to see this using Prometheus, and also Spring matrices. We're going to see all of this. We use attack surfaces again. With simplified authentication, it reduces attack surfaces. And if you design good, you get to avoid common attacks such as URL, getting data from the URL, privilege escalation, by not using data leakage. You get to avoid all of those simple attacks, SQL injections and stuff. We're going to see them. Enable scalability. Again, it's very easy to scale a good designed API. So what comes next? We're going to build a basic Spring Boot application, apply these design principles, and we're going to create endpoints, right? Prepare for security hardening. So these are our foundational courses. We have come to the end. of this particular lesson, and this I think this is our end of the foundational lessons. And in the next video we're going to we're going to dive into the fun stuff. Of course, I know you have been waiting. We're going to design a basic API. We're going to not use the I'm going to purposely make some errors that we have all made when we are learning, just to allow us to slowly implement these safety measures and get to see them in practice and how they actually protect the APIs, right? So when you see me actually designing and not using certain like the JPA or the ORMs, actually using native queries and making those mistakes, so just bear with me. It's intentionally, it's by intention, right? It's by design, by my design. And in later classes, in later courses, we are going to see how to safely prevent attacks. We're going to see the attacks, we're going to test the vulnerability, we're going to explain them, and then we're going to see how our updated design get to prevent those vulnerabilities. For my experience, this is the best way to teach this course, and it makes understanding much easier. All right. So the next classes, we're going to be diving right into security. Again, security is essential. We're going to design with security in mind first. Then we're going to in very later classes, we're going to talk about fault tolerance, and then we're going to talk about optimization. So thank you very much for watching. Again, like, subscribe, and comment your thoughts and any questions you have in the comment below. And resources for my resources, the link to the resources, that's the Git repository where I get to upload all of these notes, and the code which we're going to be working on are going to be left in the description below. My socials are also in the description below, so I appreciate a follow and a like. So thank you for watching. I have Ngane Emmanuel, and until next time.